Hello, and thank you for joining us. My name is Ann Fitz, and I am a product engineer on the ArcGIS API for JavaScript team. And I'm here today with my colleague, Christian Ekenes, who is also a product engineer on the JavaScript API. Today we're going to talk to you about clustering and show you some great demos. So before we get started with the demos, I just wanted to point out that all the code shown today and the slides will be available at this GitHub repository if you follow the link arcg.is/mvpx8. So for those of you who don't know, clustering is a form of feature reduction that groups features in a similar location on the map into a single symbol or a cluster. The size of this feature depends on the number of features it represents. So more features equal a bigger symbol. So let's take a look at our first demo where we will add clustering to a feature layer with a simple renderer. So to start out, we have a feature layer with a simple renderer on a dark gray base map. And here we're setting the view and adding an expand widget with a legend to give us a bit more information about the layer. So let's just look at what this looks like before we add any clustering. All right, so here you can see that we have a lot of point data for homicides in Philadelphia. Sorry, I know this isn't the most uplifting map, but so with so many points, it can be difficult to see where a majority of these homicides occur, if there are any patterns and where they're occurring, and that's where clustering can come into play. So let's go back to our demo and add clustering. So to add clustering, we are going to set the feature reduction property on the layer and set the type to cluster. And that's all. So now let's go back and look at our app. Let's refresh. And now we can see that the features are now clustered together based on their location, and the size of the cluster reflects the number of features in that area. So we can see that there's a bit more activity happening up here than there is down here in this area. And it's also important to note that the rendering of the cluster matches the rendering that we had on the features initially. It's just this red point symbol. So now that we have clustering, this still doesn't tell us too much about the data, like how many features are clustered in here versus how many features in this cluster. So that's something labeling can help with. So let's go back to our app. So to add labeling to the clusters, we need to set the labeling info on the feature reduction property. So I'm just going to copy and paste this snippet just for time's sake. But here you can see we're setting the label info. So the important things here, we're setting the label expression info so that it will take the cluster count of the clustered feature and format that output. And then we also can set the font of the label, and then we can decide where we want to place it. So in this case, we're putting it in the center of our cluster. So let's take a look at what that looks like now in our app. I'm going to refresh. Okay, so now you can see we have the number of features displaying in the side of the cluster. But for some of these smaller clusters, like down here, the label is kind of overflowing from the sides. It doesn't look very good. So to fix this, we can update the min and max cluster size so that the label fits within the bounds of the cluster. So these properties are set by default, but there could be some situations like this one where you want to adjust the size manually. So we're just going to go ahead and bump the cluster min size up to 16 pixels and the cluster max size up to 60 pixels. All right, now let's go back to our app and refresh again. And now you can see that these smaller clusters, they got a little bit bigger, but they definitely hold the label a lot better than they did before. So this is just a simple labeling example. We're just showing the amount of clusters in the amount of features in the cluster. But you can get as complex as you want with your labeling. For instance, let's check out this clustering sample from our documentation. So in this sample, you can see that the labeling is a little bit more complex. We are giving a label to our label and telling what type of features we're looking at. So in this case, we're looking at power plants. There's also this label up here, which is showing the predominant power plant type in that cluster. And then also if we look at this legend, if we filter through the features, our labeling also changes. So here you can see that the number of power plants is down here, and then this is showing the megawatts of capacity. So let's just take a look at what that label class looks like down here. So as you can see, this is the labeling info that is set on the feature reduction property, and I can just keep scrolling. It is very long. So this just shows that you can really get pretty crazy with your labeling on your clusters. Okay, so let's go back to our demo. So the next thing we want to do is add a pop-up to our cluster. And this can be done pretty simply by adding the Popup template property on the feature reduction class. And here we're just going to set the content. So we're going to say this cluster represents cluster count homicides, where a cluster count is an aggregate field that indicates the number of features summarized by the cluster. So let's go back to our demo and we'll refresh and click on a pop-up. And now you can see we get this cluster represents 214 homicides. So next, let's see how clustering works when we use a different renderer. So right now we're using a simple renderer. Let's try it with a unique value renderer. So I'm just going to replace this existing renderer here with this unique value renderer. And let me just clean that up. Okay, so now we're basing the rendering off of this disposition field, differentiating between cases that were closed without arrest, closed by arrest, or remain open and no arrest has been made. And each of those types will have a different symbol. So since the renderer of the cluster matches the renderer of the layer, when we go back to our app and we refresh, we should see that the cluster will be represented by the predominant field in the renderer. So you can see that homicides in this area remain open, majority of them remain open, whereas over here the majority are closed. And as we zoom in and out, this changes based on the features within the cluster. So now that each cluster has a predominant type shown, we can also use this information in our pop-up. So let's go back to our code and we'll add some more information to our pop-up template. So here we're adding another text type to our content, and we're saying the predominant case status is this cluster type disposition, and that will give us the predominant disposition in the cluster. And this can work with any field name that you use to render your layer. It'll just be of the form cluster type, and then this disposition would be replaced with whatever field name you are using. Okay, so let's go back and see what that looks like. Great, so let's click one of them, and you can see that the predominant case status, closed by arrest, has been added. So next, let's take a look at what happens when we apply some visual variables to our layer. So we're going to go back to that simple renderer app, and instead of changing the renderer completely, we're just going to add some visual variables to our renderer. So here we're just trying to visualize the age of the victims in the data by color. So we're going to give a different color based on the value or age of the victim. And since the data from the layer is now being visualized by color based on a number, the rendering of the cluster will be based on the average age of the victims within that cluster. And similar to the example with the unique value renderer, that also gives us a new aggregate field that we can add to display in the pop-up or display in the label. Let's try adding it to the pop-up. So here we are. I'm going to add a new pop-up content, just another type text, and we're going to show the average victim age by using cluster underscore average and then the field name that we want to show. So in this case, it's victim age years. Let's go back to our app. Let's refresh. We can see that the rendering of our clusters has updated based on the age. It seems like the average victim is somewhere in the middle here, around age 30. And if we actually click on one of these clusters, then we can see that the average victim age for this cluster is 30. So that's kind of all I had for you today. But before I pass it off to Christian, I just wanted to point out some of the other samples that we have in our SDK. This one is just a basic configuration, so kind of what we went through today with a simple renderer and a simple pop-up and simple labeling. But it does have this nice button that is added to the legend that allows you to disable and enable clustering. So that's something that's pretty cool. Also, we talked about this sample already, the advanced configuration with advanced labeling and filtering. But I also just wanted to show the pop-ups that are here. So this is a little bit more advanced than what we were doing today. It's using a lot of different features and attributes to make this pop-up. So definitely look at this example if you're trying to do more with your pop-ups. And then there's another example using visual variables, and this is using the rotation visual variable and the color visual variable. So there's a lot going on here, and also a really great pop-up to look at there. But yeah, so that's all I had. Now I'm going to pass it off to Christian, who will talk to you about generating suggested configurations for your clusters and also querying your clusters. Take it away, Christian.
All right, thank you, Anne. As Anne stated at the beginning, my name is Christian Ekenes, and I'll be covering a couple of scenarios with clustering that are designed to help you out as the developer. But before I dive into these, I want to just cover a couple of things. So, as Anne pointed out, you have complete control over configuring the pop-up template and the label inside your feature reduction for clustering. This is a huge advantage to you as a developer, but it can also be a little difficult to know exactly how to define that content. These aggregate fields, such as cluster average, wind speed, may not always be obvious to you as the developer. You may not know what the field name is that you're working with. Perhaps the layer is configured with an arcade expression, and so the name of the aggregate field in clustering isn't obvious. So how do you reference that in the pop-up? You may also struggle with labeling or other cluster properties even. So what cluster radius should you be using, or what are the min and max sizes? What kind of symbol should you be setting on your label? What size should it be? What's the most legible label? What if I have thousands or millions of features, so the label that I've configured before no longer fits inside my cluster? These are all real scenarios that you need to account for. And so for that reason, we've designed a few functions that will help you get started with understanding how to configure that. I've opened up the JavaScript API reference here, and you'll notice that there's an Esri Smart Mapping folder. Within that, you have a lot of utility functions that are designed to help you get started with things such as rendering, pop-ups, labels. If you expand the labels folder, you'll see a clusters module. Same with the pop-up module. Within each of these, you'll see one method that is designed to help you get started with a good label scheme for your clusters, or alternatively for a good pop-up scheme, or pop-up template rather, for your clusters. So get templates. So that's what this slide is showing right here. It actually really shows the simplicity is with working with default pop-up templates and labels. So in this example to the left, you see a nicely configured label. Some of these contained thousands of features, and if we didn't format them in a particular way, that label might not look good. Well, this snippet shows how easy it is to work with these creator functions, as we call them. All you have to do is import the module, and then you call the desired method. So if you want to get a good default pop-up template that matches your renderer, just simply provide the layer, and then you will get a suggested pop-up template that matches the renderer for that layer. The same goes for labeling. So simply call the get label schemes method, provided a layer into view, and you'll get a label scheme that will work well with the layer. And so let's go ahead and look at a live example of this. So I have a data set of places of worship in India, and it's the layer. If I disable clustering, you'll see that each point is colored based on the type of religion that belongs to that place of worship. When I enable clustering, as Anne pointed out, the predominant place of worship the color representing that predominant place of worship will represent that cluster. So how do I get this nice label? And when I click this pop-up, how do I get this nice pop-up that tells me what that predominant religion is, along with the number of features? So here's my code off to the left here, and I've created this generate cluster config function. And as you can see, I call that when the layer loads, and when that promise resolves, I simply set it on my layer, and I get this nice pop-up and label configuration. Well, let's go ahead and hop down to that function. And you can see that very same snippet you saw in that slide there. I've imported the pop-up creator module, passed it my layer. I've also imported this label creator module, given it my layer and view. And back comes a pop-up template, labeling info, and you'll also notice a cluster min size. The reason we provide a suggested minimum size for your cluster is so that we guarantee that the small numbers actually fit inside your cluster. If I were to look at the expression for the labeling that's generated, this is what it would look like. It's just getting the cluster count aggregate field, and then it checks to see how long the label is, and it shortens it appropriately based on the number of features. So this is a really handy tool that allows you to quickly get set up with a nice default label and a good default pop-up template. Most of the time, you don't really need more than that, but there are scenarios where you want to do more, and that's what we're going to cover next. So now let's talk about querying clusters. This is a pretty new feature in the JavaScript API. It was just released in December 2020 with our 4.18 version. Many times you encounter scenarios where simply saying the cluster count in the label or in the pop-up isn't good enough, or even the predominant type is not enough information for the user. If you have multiple types that you want to break down, you can do that with cluster queries. And in this example, you basically see how it works. The cluster querying works very much the same as layer view and layer queries. All you have to do is create a query object from your layer view, and then you pass in the object ID of the graphic representing your cluster to that query object. And then you query your layer view just as you would any other time you're doing a client-side query. And when you get the result back, you get a feature set, and then you can do anything you want with those features. You can add them back to the view, you can allow your user to browse them, or you can calculate statistics and display it in a table, such as in this example to the left. So let's go ahead and look at a live example of that. So I've got a layer here representing power plants across the world. and it's colored based on the fuel type used to generate the power in each plant. And again, you see the color taking on, or the cluster taking on the color of the predominant type. Well, I've created a more complex pop-up template that allows me to explore this data more fully. This is the default I get from that pop-up templates creator that I showed you before. But I also add a few actions to the pop-up, such as statistics. So now, not only do I see the number of features, but I can sum the total capacity of power plants within that cluster. And then I could break it down by fuel type and order it by the number of power plants in that cluster. So you can get as detailed as you want in these cluster queries. You can also summarize the area encompassed by features in the cluster, such as the convex hull. Maybe you just want the extent itself. And just for demo purposes, I've decided to show all features here in the view, though I don't typically find this very useful. Perhaps the more useful approach is this browse features option. Let's actually zoom in a little more because over 1,000 features is a little too much to browse. So I'm going to browse features again. And if I click this option up here, I can actually see the names of each of these power plants. I can select one, and now I can see the location of that power plant on the map, and I view its pop-up template up here in the views pop-up. And then I can browse as I would, and then I can browse the features just like so. So that's pretty powerful. What does the code look like to accomplish that, though? So if I scroll down, this is the code here that generates that pop-up template and title. But after I generate the pop-up template, I then set up these actions. That's what allows me to get all of these buttons to show up in the pop-up. Once those are set up, I can then set up this trigger event action, this trigger action event handler, and that'll allow me to set up functions that will execute when the user clicks a particular action. For example, if I want to show the convex hull, I can call this function. And what I do is I check to make sure that this graphic is a cluster, and if it is, I'll get that object ID, pass it to my query object, query my features, get all the geometries, and then I can use the geometry engine to calculate that convex hull. And I simply add it back to the view. What about browsing features? It looks very similar. You set it up by getting your query object, you pass in your object ID for the cluster, get all the features back, and all you really have to do is pass all those features back to the view pop-up. So when I click this, that's what's happening here. And as I move through, browse these features, that's what allows the pop-up to know which template to show. Now, what about showing it in the view here? That's what's going on down here. I'm just setting up a watcher on the selected feature property of the pop-up, and then I get the symbol that it's used to render it when clustering is disabled, and I add it to my view. And when the user selects another feature, I'll remove that previous one and add the new one. So it's really just a few lines of code that gives you the ability to allow your users to do some pretty powerful things to explore features within their pop-up. Now you could even take it a step further and set up some charts. So I've got an app here showing the homicide data that Anne was demoing earlier. This is the city of Chicago, and I've clustered these homicides. So now you can see them clustered by colored by the predominant status of the case. Is it still open or is it closed? When the user clicks a cluster, they see the convex hull. So this shows basically the area that is under consideration for the features in these stats. I'll display the total, but then I can break down my stats, the status of the case by year, by age, and also by status, gender of the victim, and race. So you can create some interactive charts that allow people to explore these clusters, and it's pretty cool. I can see how this data changes by area, and that's really what mapping this data is all about. So hopefully you've been inspired in this demo theater to cluster your data first off, and then to take it a step further and explore it some more, give your users the ability to explore their data through clusters with complex pop-ups or even charts and cluster queries. So I encourage you to please provide your feedback for this session. Just click the session survey link directly below this video and tell us how we've done as presenters and whether this content was relevant for you and your work. And on behalf of Anne, myself, and others on the JS API team at Esri, we want to thank you for watching this demo theater.